So in Unit 7, we talked about polynomials. We're going to start Unit 8 today. Unit 8, we're going to talk about radical expressions. So what is a radical expression? Let's start with that. Radical expression are things you've seen before. A radical is a radical sign, which is like a square root sign. It could be the square root, like the square root of 25, which is 5, because 5 times 5 gives you 25. It could also be the cube root of 8. A cube root means that there are 3 things that multiply together to give you the number inside the radical sign. And in this case, it's 2, because we know that 2 times 2 times 2 gives you 8. 2 times 2 is 4, and then 4 times 2 is 8. So we can have a 4th root or a 5th root. But this is the radical sign, and so is this here. And so when we talk about a radical sign, we have the radical sign itself, we have the radicand, which is the number underneath the radical sign, and then we have the index. The index is like square root. If there's nothing there, that means there's 2 numbers that multiply together to get that number inside the radical sign, which is the radicand. And if it's a 3, like it is here, there are 3 numbers. We can also have the 4th root or the 5th root. But for our purposes, we're going to mainly talk about square roots. And so let's begin by talking about perfect squares. Perfect squares between 1 and 100 are 1, 4, 9, 16, 25, 36. It is also, you could say 49, 64, 81, and 100. And why are those perfect squares? And that's because if we took the square root of all of those numbers, like the square root of 1 is 1, the square root of 4 is 2, because 2 times 2 is 4, the square root of 9 is 3, and so on. We could then say the square root of 49 is 7, the square root of 64 is 8, and the square root of 81 is 9. And so these perfect squares are going to be numbers that are going to be very important throughout this entire unit. That's going to be something you're going to want to put in your notes and maybe highlight or box around it, because you're going to need to know what the perfect squares are. But what if they're not perfect squares? If this was the square root of 25, we would just say it's 5. If it was the square root of 16, we would just say it's 4, because 4 times 4 is 16. So the square root of 20 isn't a perfect square. You can try it on your calculator, and you're going to get a decimal that goes on forever. That's an irrational number. But what we want to do, if it's not a perfect square, is pull as much stuff out of the radical sign as we can. So one of the things we probably want to do is factor 20 into a perfect square. What is one of the perfect squares that goes into 20? Well, the perfect squares are 1, 4, 9, 16, and so on. But we know that 4 goes into 20. So we can write this as the square root of 4 times the square root of 5. And the reason we picked the square root of 4 is because we know the square root of 4. The square root of 4, that's 2. We don't know the square root of 5, so that's going to stay inside the radical sign. So a lot of people make the mistake of saying, well, I can say it's the square root of 10 times the square root of 2, but that doesn't help you, because we don't know what the square root of 10 is, and we don't know what the square root of 2 is. And so factoring 20 into 10 times 2 doesn't really help us. But if we write it as the square root of 4, that does help us, because we know that the square root of 4 is 2. Let's try another one. Square root of 18. Again, if this was the square root of 16, we would know that it's 4, but it's not 16, so we want to find a perfect square that goes into 18. So it's 1 and 4 and 9, and 9 goes into 18, so we can say this is 9 times 2, because the square root of 9 times the square root of 2 is the square root of 18. And the square root of 9, we know, that is just 3. And so this is 3 times the square root of 2. So when we simplify radicals that aren't perfect squares, what we're doing is we're pulling as many factors that are perfect squares outside of the radical sign. So let's try some on your own. Square root of 75. I'm going to have you pause the video, and then once you think you have the correct answer, restart the video and see if you have it correct. So square root of 75, 4 doesn't go into 75, neither does 9, neither does 16, but 25 does. So we can write this as 25 times 3. And I know that the square root of 25, that's the same thing as 5. So it's 5 radical 3. If I do the same thing with 72, there's really two ways to do 72 here. I could find the biggest square that goes into 72, which is 36. 36 times 2 is 72. And we know that the square root of 36, well, that's 6. So it's 6 radical 2. But suppose you didn't pick 36 right away. Suppose you said that 72 is the same thing as radical 9 times 8, because you know that radical 9 is a perfect square. The square root of 9 is 3. Well, then we could still simplify the square root of 8. What's a perfect square that goes into 8? Well, 4 does. 4 times 2 is 8. And we know that the square root of 4 is 2. So that becomes a 2. Now we can multiply the 2 and the 3 together to give us 6. And we still have the square root of 2. And so either way, we get 6 times the square root of 2. There's another way that we can do these factors of numbers, and that is the factor tree. For example, there are some teachers that would tell you that if you want to simplify the square root of 75, you just do a factor tree here. We can say that 75 is, let's say, 5 times 15. 15 is 5 times 3. And then you can pull them out in pairs, because the square root of 5 times the square root of 5 is simply just 5. And so if you pull them out in pairs, the 5 come on the outside, and then you have a radical 3 left on the inside. So it would look like that. We could do the same thing with 72. We could say 72 is, let's just say it's 2 and 36. Let's say that 6 and 6 give us 36. 2 and 3 give us 6. And another 2 and 3 give us the second 6. So let's take them out in pairs. So here I have a pair of 3s. Here I have a pair of 2s. So I have the 3 comes on the outside. I have the 2 comes on the outside. But then I have this 2 that doesn't have a partner, so it has to stay inside the radical sign. 3 times 2 is 6, radical 2. And so I would get the same thing that I got using the other two methods. So let's try some of these with variables. So if I were taking 4 times the square root of 4n squared, that's the same thing as writing it as the square root of 4 times the square root of n squared. The square root of 4 we know is 2, and the square root of n squared is just n. I can pull them out in pairs. It's the same thing with numbers, because I can write 4 as the square root of 2 squared. 2 squared is 4, and the square root of 4 is 2, so this is just 2. If I had 3 squared, and I took the square root of that, well, that would just give me 3, because 3 squared is 9, and the square root of 9 is 3. If I had 4 squared, and the square root of that, well, the square root of 4 is 16, and the square root of 16 is 4. So if I have a pair of anything, it can come outside of the radical sign as a single number. And that's what I did with the square root of n squared. The square root of n squared is just n. Let's take a look at something that's not perfect squares. The 12 is not a perfect square, but I could write the 12 as 4 times 3. We know that the square root of 4, that's 2. The square root of 3 we don't know, so that's going to stay inside the radical sign. But then I have 3 n's. Well, I can write 3 n's as n squared times n. These will come out of the radical sign, and this n here has to stay inside the radical sign. Because if I were to write the square root of n squared is just n, and then I can't take the square root of just one n, so that has to stay inside the radical sign. So my answer here, the square root of 12n to the third simplified, would be 2n on the outside, but then I can't pull the 3n out, so that has to stay inside the radical sign. And I would say this as 2n times the square root of 3n. Let's try some here on our own. Square root of 500, I'm going to have you pause the video, see if you can do this one on your own, and if not, watch the video and I'll help you through it. So hopefully you're able to do something like this. If we just work with the 500 first, we can write that as 100 times 5. And the reason I picked 100 is because I know that the square root of 100 is 10. I don't know what the square root of 5 is, so that's going to stay inside the radical sign. But then my n to the 5th, that's going to come out in pairs. So it would be the square root of n squared, another square root of n squared, and then another n left over. Well, these are two n's on the outside. Square root of n squared and the square root of n squared, that's n times n, which is n squared. In other words, two pairs of n's can come out, but then I have one n left over that has to stay inside the radical sign. And the square root of 500 n to the 5th would simplify as 10n squared times the square root of 5n. Let's try one more here. Again, if you can pause the video and try this one on your own first, that would be great. If not, we'll work through it together. What's a perfect square that goes into 44? Well, I know 4 does. 4 times 11 is 44. And 4, that is just the number 2. The square root of 11, I don't know. So that's going to stay inside the radical sign. Well, then I have two x's. Those get to come out because they're in pairs. So there's one x on the outside. But then I have 5 y's. Well, that's two pairs on the outside, so it's y to the 2nd on the outside. And then there's one y that doesn't have a partner that has to stay inside the radical sign. So my final answer is going to be 2x y squared times the square root of 11y. Hopefully this all makes sense. This is what our homework assignment is about today. We'll do well on that, hopefully, and if you have questions, we'll go through it tomorrow in class.